Okay, Bismillah ar-Rahman ar-Rahim. We'll continue. Now we finish all the exam for the section 6.1. Now we'll do questions from the book. Find real eigenvalues and associated eigenvectors of a given matrix. Find the basis for each eigenspace of dimension 2 or larger. 2 or larger. Okay. So I need to find the eigenvalues. This is my A. So I'll do A minus lambda I. That will be 4 minus lambda minus 2, 1, 1 minus lambda. That gives me what? Lambda square minus lambda minus 4 lambda minus 5 lambda plus 4 plus 2. That will be lambda square minus 5 lambda plus 6. That is lambda minus 2 times lambda minus 3 equals 0. So the eigenvalues are what? Lambda equal 2 or lambda equal 3. Okay. Now I will check for each lambda. For lambda equal 2 with V1, K1, K2, and solve this system. A minus lambda I, V equals 0. So let me do it here. 4 minus 2, that will be 2 minus 2, 1. 1 minus 2, that is minus 1 times K1, K2 equals 0, 0. So you have actually two equations, but they are only one equation. So actually I have K1 equal K2. So K2 free variable. K2 free variable. Let K2 equal 1. I get K1 equal 1. So what is my V1? 1. Okay. Second one. Now for lambda equal 3. Edit V2. K1, K2. I need to solve this same system. For lambda equal 3. So what I have? 4 minus 3, that is 1 minus 2. 1. 1 minus 3, that is minus 2. K1, K2 equals 0, 0. I did need to find the basis for the eigenspace, so the dimension is not 2, dimension is 1. Huh? So I have what? K1 minus 2, K2 equals 0. K1 minus 2, K2 equals 0. So I have K1 equal to K2. So I have K2 free variable. So I need K2 to be 1. So K1 equal 2. So I have what is V2? V2. That's it. Okay. Question 3. I'll do the same thing. A minus lambda I. And these easy ones. That will be 8 minus lambda minus 6, 3 minus 1 minus lambda. That gives me what? Lambda square minus 8 lambda plus lambda minus 8 plus 18. That gives me lambda square minus 7 lambda plus 10, which is lambda minus 5 times lambda minus 2 equals 0. So the eigenvalues lambda equal 5 and lambda equal 2. These are the eigenvalues. Now for lambda equal 5, let me start from lambda equal 5. I need to find the eigenvectors. Let V1, K1, K2, and solve this. A minus lambda I, V1 equals 0. What you will get, 8 minus 5, that will be 3 minus 6. And that's 3 minus 1 minus 5 is still minus 6. So you have what? 3K1 minus 6K2 equals 0, and the same thing. So actually I have K1 equal to K2. So K2 free variable. Let K2 equal 1. I'm getting let K2 equal 1. I'm getting K1 equal 2. So what is my V1? Is 2 and 1. V1 is 2. Okay. Yeah. Now for lambda equal is dimension 1, so no need to find basis. Okay. He said we'll leave dimension 2. Okay. So okay, for lambda equal 2, what I have? I let V2, K1, K2, and I want to solve this. A minus lambda I, V2 equals 0. Lambda is 2, so I have 6 minus 6, 3 minus 3, K1, K2 equals 0, 0. So I have 6K1 minus 6K2 equals 0. 3K1 minus 3K2 equals 0. Actually, I have K1 equal K2. So K2 is free variable. I let K2 equal 1. K1 will be 1. So my second vector is 1. That's it. 7. Okay, do the same thing. Yeah, these 2 by 2 are easy ones. But 9 minus lambda minus 5, 4. This is 0 minus lambda, so it's minus lambda. So you have lambda square minus 9 lambda plus 20, which is lambda minus 5 times lambda minus 4 equals 0. So the eigenvalues, lambda equal 5 and lambda equal 4. So for lambda equal 5, let V1 equals K1, K2, and solve this. A minus lambda I, V1 equals 0. Well, lambda is 5. So I have what? 9 minus 5, that would be 4. Minus 5. 4 minus 5 times K1, K2 equals 0, 0. So I have what kind of equations? 4K1 minus 5K2 equals 0. And the same thing here. As usual, I should have infinitely many solutions equations. So I have what K1 will be 5 over 4K2. So K2 free variable. But in this time, I will let K2 to be 4 to avoid fraction. So K1 equal 5. So it will be V1 will be 5 and 4. This is for lambda equal 5. Okay, now for lambda equal 4. Yes, the other one is what 4, yeah? I let V2, K1, K2, and solve this. A minus lambda I, V2 equals 0. So I have what? 5 minus 5, 4 minus 4, K1, K2 that will be equal 0, 0. So you have 5k1 minus 5k2 equals 0, and 4k1 minus 4k2 equals 0. Actually, have k1 equal k2. So k2 a free variable. So let k2 equal 1. So k1 equal 1. So what is my v2? 1. And that's the eigenvectors. Okay. Now it becomes more interesting. I have 3 by 3. Now the calculations will be a little bit harder. Let me see what will happen. I need to do a minus lambda I. That give me 5 minus lambda 0, 0. That's good. 4 minus 4 minus lambda minus 2 minus 2, 12. 6 minus lambda. So that is what I will do, the expansion with the first row since I have zeros. So I have 5 minus lambda. The rest is what? Minus 4 minus lambda minus 2, 12, 6 minus lambda. That is what? 5 minus lambda times what? Times lambda square. Okay. Minus 6 lambda plus 4 lambda. That is minus 2 lambda. Minus 24 plus 24. So that will be 5 minus lambda. This is cancelled. I can take lambda common factor. I have lambda minus 2 equals 0. So what are the eigenvalues? Eigenvalues are lambda equals 0, lambda equals 2, lambda equals. I'll do them one by one. So for lambda equals 0, what we have? Yeah, I let v1 now. k1, k2, k3, and solve this. A minus lambda I v1 equals 0. To solve the system, that will be 5, 0, 0, 4 minus 4 minus 2 minus 2. I'm subtracting zeros, so I'm having no change. 0, 0, 0. What I have 5k1 equals 0, which is gone. I have these are 3 equations, 3 unknowns. Solve it the way you like. Yeah. So sometimes you'll do just calculations. Sometimes you'll do what is it? You do Gauss elimination. Do it the way you like. Here I have k1 equals 0. That's it. So that means this equation becomes what? It becomes minus 4k2 minus 2k3 equals 0. And this equation the same, 12k2 plus 6k3 equals 0. If you notice, these are the same. If we divide by minus 2, the first one, you get what? You get by minus 2, the first one, I have 2k2 plus k3 equals 0. If I divide by 6, the second one, you get the same equation. So actually I have k3 equal minus 2k2. So I can take k2 a free variable. So let k2 equal 1. K3 will be minus 2. So it is my V1. That will be K1 is 0. Next, this is 1. This is minus 2. Yeah. You can take K2 minus 1. You can. It's up to you. Okay. Now for lambda equal, what will be the next one? 2. What we have? I let V2 to be K1, K2, K3. I want to solve this. A minus lambda I v2 equals 0. So this will be 3, 0, 0. I have 4, be careful now. Minus 4 minus 2, that will be minus 6 minus 2. Minus 2, 12, 6 minus 2, that is 4 times k1, k2, k3 equals 0, 0, 0. I think I have the same thing. So I'm getting what? 3k1 equals 0, which means k1 equals 0. Second one, I have what? Plus 4k1, which is 0. So I have minus 6k2 minus 2k3 equals 0. And I have 12k2 plus 4k3 equals 0. These are the same. If I divide by minus 2, I'm getting what? 3k2, just to show you they are the same. And this I divide by 4, I'm getting 3k2 plus k3 equals 0. So I have the same equation. So I say k3 equal minus 3k2. So k2 is free variable. I let k2 equal 1. So k3 will be equal to minus 3. So what is my b2? Will be 0, 1, minus 3. Okay. Now the last one, for lambda equals 5. I let v3 now. k1, k2, k3. And solve this. A minus lambda I b3 equals 0. So I have 0, 0, 0. Okay. 4 minus 9 minus 2. Is it? Yeah. Minus 2, 12, 6. Minus 2, 12, 6 minus 5. That will be 1. Times k1, k2, k3 equals 0, 0, 0. I want to solve the system. Yeah. One way to do it is through Gauss elimination. I think it will be good, Gauss elimination. So just the first, I will make the first row the third row and the third row the first row. So I have minus 2, 12, 1. This is 0. This is 4 minus 9 minus 2. This is 0, 0, 0. Now multiply the first row by 2 and add the second row by 2 and add, that will be 0. That will not be changed. Okay. Multiply by 2. 24 minus 9 is what? 15. Multiply by 2 and add it, that will be 0. So what I have now? I have minus 2k1 plus 12k2 plus k3 equals 0 and 15k2 equals 0. So I have k2 equals 0. And from here, I have k3 equal to k1. So I can let k1 to be, let k1, k1 is my free variable. I let k1 to be 1. What I'm getting, k3 will be 2. So what is my v3? Will be k1 is what? 1, k2 is 0, and k3 is 2. 1, 0, 2. Perfect. Okay, let me do another problem, which I think easier. It has a lot of zeros. Yeah, still have. I'm trying to do good number of problems. Okay, so I have a minus lambda I, 3 minus lambda, 5 minus 2, 0, 2 minus lambda, 0, 0, 2, 1 minus lambda. Yeah, 3 minus lambda times the rest. That gives me 3 minus lambda, 2 minus lambda, 1 minus lambda equals 0. So what are the eigenvalues? Lambda equal 1, lambda equal 2, lambda equal 3. Now for lambda equal 1, I need to be 1. And solve the system, has no need to write it every time. So we have what? 3 minus 1, that will be 2. 0, not 2, 5 minus 2. 0, 1, 0, 0, 2, 1 minus 1, that will be 0, times k1, k2, k3 equals 0, 0. So I'm getting what? I'm getting 2k1 plus 5k2 minus 2k3 equals 0, k2 equals 0, 2k2 equals 0. From here, I'm getting k2 equals 0. Put it there. I'm getting what? 2k1. Yeah. 2k1 minus 2k3 equals 0. So k1 equal k3. So my k3 is a free variable. My k3 is a free variable. So I let k3 be equal to 1. So k1 will be 1. So it is my v1 will be. My v1 for lambda equal 1 will be 1, 0, 1. 1, 0, 1. Yeah, that will be. Now for lambda equal 2, let me see what will happen. I let v2 I'm looking for this v2. So I have 1, 5 minus 2, 0, 0, 0. Lambda is 2. So I'm looking at 0, 2 minus 1 times k1, k2, k3 equal 0, 0, 0. So I have what? K1 plus 5 k2, k1 plus 5 k2 minus 2 k3 equals 0, 0, 0. I have 2 k2 minus k3 equals 0. So from here I have k3 equal to k2. I plug it in the first one. Plug it in the first one. I have what? K1 will be equal to k3 minus 5k2. And k3 is 2k2, so I have minus k2. So my free variable, so k2 is my free variable. So I let k2 to be 1. I have k3 is 2. And k1 is minus 1. So it is my v2 minus 1, 1, 2. That's the answer. Okay. Now I need the last one, lambda equal 3. Now for lambda equal 3, I let v3 to be k1, k2, k3. I solve the system. I have 0, 5 minus 2. Next one is 0, 2 minus 3, which is minus 1, 0. And the last one is 0, 2, 1. So that will be 0, 2, minus 2. Times k1, k2, k3 equals 0, 0, 0. So what I have 5k1 minus 2k 5k2 minus 2k3, that will be equal to 0, and minus k2 is equal to 0, and 2k2 minus 2k3 equals 0. Here I'm getting k2 equals 0, plug it there, so I have k3 equals 0, which is okay in this. So do you have a free variable? Yes, there's no restrictions on k1. So k1 is my free variable. So I did k1 to be 1. That's it. So I have v3 will be 1, 0, 0. Okay. Next one. Okay. Now I think it comes where we have a repetition. Yeah. I'll do a minus lambda I. And this is will be what? 3 minus lambda, 6 minus 2, 0, 1 minus lambda, 0, 0, 0, 1 minus lambda. That give me what? 3 minus lambda. I will do expansion with the first column. I have what? 1 minus lambda, 0, 0, 1 minus lambda. That gives me 3 minus lambda, 1 minus lambda square equals 0. So what are the eigenvalues? Lambda equal 1, lambda equal 1, lambda equal 3. Now let me do for lambda equal 1, see what will happen. I let v1, I don't know, is it v1 or v1 and v2? Let us see what will be the equation. It will be 2, 3 minus, wait a minute. Yeah, lambda equal 1, that will be 3, 6 minus 2, 0. With 1, that will be 0, 0. And then 0, 0, 0 times k1, k2, k3 equals 0, 0, 0. That means what? I have 2k1 plus 6k2 minus 2k3 equals 0. I have only one equation. So I have k1 will be what? K3, take it the other side, and divide by 2 minus 3k2. So that means what? I have two free variables. So it means k1 free variables are what? K2 and K3. So I can do this trick. I let K2 equal 1 and K3 equal 0. And the same thing, K2 equal 0 and K3 equal 1. If I do this, what will be K1? In this case, K1 will be minus 3. And in this case, K1 will be 1. So I have two fees. I have V1 will be what? Minus 3, 1, 0. That will be V1. And V2 will be what? 1, 0, 1. That will be my V2. Now we'll go to for lambda equals what? Equals, what is the next one? 3. That I think will be easier. I let V3 now. Oh, by the way, now I have an eigenspace. My eigenspace, because the dimension is 2 here, will be all V in R3 that A minus lambda I, where lambda is 1, V equal 0, which will be spanned by V1 and V2. And also I can write it alpha times V1 plus beta times V2, such that alpha and beta are real. And so it's 2-dimension, and the bases are V1 and V2. Now we'll come to the last one for lambda equal, what is it? 3. It solved the system. So I let now V3 to be K1, K2, K3. I have what? 0, 6 minus 2, 0, 1, 0, 0. No, it's not 1. It's minus 2. 0, minus 2. Times K1, K2, K3 equals 0, 0, 0. So I have what? 6K1, 6K2. There is nothing about K1. 6K2 minus 2K3 equals 0. Minus 2K2 equals 0. Minus 2K3 equals 0. So I have K2 equals 0, and I have K3 equals 0. Oops. And that's okay with this one. So K1 is my free variable. The free variable. There's no restriction on K1. So I did K1 to be 1. So it is my V3. 1, 0, 0. No need to this space. Now we'll do this one. 3 by 3. So I have A minus lambda I. See what will happen. I have what? 7 minus lambda minus 3, 1, 8 minus 3 minus lambda 2, 0, 0, 3 minus lambda. I'll do the expansion with the first row. Plus, minus, plus, minus, plus. So I have plus 3 minus lambda. What will be the rest? Cancel this with this. I have what? No, sorry. This with this. I have 7 minus lambda minus 3, 8 minus 3 minus lambda. That give me what? 3 minus lambda times what? This is lambda square. 3 lambda minus 7 lambda minus 4 lambda minus 21 plus 24. That will be 3 minus lambda times what? Lambda square minus 4 lambda plus 3, which is 3 minus lambda times lambda minus 1 times lambda minus 3 equals 0. So the eigenvalues, lambda, we can say lambda 3 multiplicity 2, or we can say 3 and 3, and lambda equal 1. Okay, you can do it this way. Now, so let me do for lambda equal 3. See what will happen. Shall I get 2 vectors or only 1 vector? Let us see. Okay. I let V1 to be K1, K2, K3. I need to solve this system. It will be what? 7 minus 3, that will be 4, minus 3, 1. Then I have what? 8. Minus 3, minus 3, that will be minus 6, 2. The last one I have 0, 0, 0. So what we have? We have 4K1 minus 3K2 plus K3 equals 0. And I have 8K1 minus 6K2 plus 2K3 equals 0. Note these two equations are the same. Multiply the first by 2, you get the second. So I have only one equation. So I will say K3 will be equal 3K2 minus 4K1. Okay, so my free variables are K1 and K2. So do this trick, let K1 equal 1 and K2 equal 0 and K1 equal 0 and K2 equal 1. What are we getting? I'm getting what? If K1 1 and K2 0, K1 1 and K2 0, K1 1 and K2 0, I have what? K3 is minus 4. Is it? Check 0. Okay. K1 equals 0, K2 equal 1. I have K3 equals what? K2 equal 1, I have 3. I have V1 will be 1, 0 minus 4, and V2 will be what? 0, 1, 3. You can do it in other ways. So I have now an eigenspace since I have dimension 2. So E, what is it? What is the lambda? 3 will be all V in R3. Is that A minus 3 IV equals 0. And that will be spanned by V1 and V2. And this I can rewrite it as what? Alpha 1, 0 minus 4 plus beta 0, 1, 3 is that alpha and beta are real. Yeah. And so I have 2 dimension and the bases are V1 and V2. Okay. Now for lambda equal, what is it? Lambda equal 1 now, the remaining. I let V3 now to be K1, K2, K3. Solve the system. I have what? 6 minus 3, 1. 8 minus 3 minus 1. That give me what? Minus 3 minus 1. That would be minus 4. 2. I have 0, 0, 0 times K1, K2, 0, 0, 0. Yeah, the last one. K3 equals 0, 0, 0. I need to solve this system now. I have 6K1 minus 3K2 plus K3 equals 0. 8K1 minus 4K2 plus 2K3 equals 0. How to solve this? Yeah. If I divide the second one by 2, I'm getting from the first one that K3, let me do this trick. K3 is what? 3K2 minus 6K1. And from the second one, if I divide by 2, I'm getting what? Divide by 2, so this is becomes 4. This becomes 2. This becomes 1. So K3 will be equal to what? K3 will be equal to 2K2 not help it. Instead of doing all of this nonsense, I need to solve the two equations in a good way. This is 8 minus 4 plus 2. So I multiply the first one by minus 2. I think this is better. I have minus 12k1 minus 2 plus 6k2 minus 2k3 equals 0. I have this is 8k1 minus 4k2 plus 2k3 equals 0. Add them, what you will get? Minus 4k1 plus 2k2 okay, this is gone, equals 0. So I have k2 is, take this to the other side, 2k1. So k1 is my free variable. So my free variable will be k1. I let k1 to be 1. Then what will be k2? K2 is 2. What will be k3? Plug it in the first equation, plug it here. I have what? K1, 1, that will be 6 minus 6, 0, so k3 equals 0. So it will be my v3. I'll just squeeze it here. That will be 1, 2, 0. Sorry. Yeah, that's good. Now we need to do 4 by 4. Need to do 3 examples. Okay. Hopefully they are quick. Do the first one. I have a minus lambda I. That will be what? 1 minus lambda. Yeah, I choose them to be easy ones. 2, 2, 2. 0, 2 minus lambda. 2, 2, 2. 0, 0. 3 minus lambda. 2. 0, 0, 0, 4 minus lambda. So I'll do expansion with the first row. Yeah, it's a matter of calculation now. They have 2 minus lambda, 2, 2, 0, 3 minus lambda, 2, 0, 0, 4 minus lambda. I'll do expansion with also with the first row. It's very clear I have 3 minus lambda times 4 minus lambda equals 0. So what are the eigenvalues? Lambda equal 1, lambda equal 2, lambda equals 3, and lambda equal 4. I need to find the eigenvectors for each one of these. Okay. So let's start for lambda equal 1. The idea is clear, but now it's a matter of calculation. Okay. So I let V1 now to be K1. Oops. K1, K2, K3, and also K4. Solve the system. It will be 1, 0, 2, 2, 2. Then it will be 0, 1, 2, 2, 0, 0, 3 minus 1, that will be 2, 2. The last one, 0, 0, 0. 4 minus 1, that will be 3. Now we need to solve the system. 2k1 plus 2k2, not 2k1, 2k2 plus 2k3 plus 2k4 equals 0. Solve it the way you like. K2 plus 2k3 plus 2k4 equals 0. 2k3 plus 2k4 equals 0. 3k4 equals 0. So from here I have k4 equals 0. Plug it here. I'm getting k3 equals 0. Plug it here. I'm getting k2 equals 0. And this is okay. So my three variables is k1. There's no restriction on k1. So I let k1 to be 1. So it will be my v1. 1, 0, 0, 0. Now take another lambda. Lambda equal to. It's not difficult, but it's a matter of calculation now. I let v2 now to be k1, k2, k3, k4. Let us see what will happen. 1 minus 2, that is minus 1, 2, 2, 2. Okay, next one is 0. Then that is 0, 2, 2. This is 0, 0, 1, 2. The last one 0, 0, 0, 2. Okay. So what I will have is 23. I have what? Minus k1 plus 2k2 plus 2k3 plus 2k4 equals 0. Then I have 2k3 plus 2k4 equals 0. And I have k3 plus 2k4 equals 0. And I have 2k4 equals 0. So from here, I'm getting k4 equals 0. Plug it here. I'm getting k3 equals 0. And this is okay. So I have this is 0, this is 0. So I have from the first one, k1 will be equal to k2. So my free variable is k2. So I let k2 to be 1. So it will be k1, 2. So it is my v2 will be 2, 1, 0, 0. Yes. Now for lambda equal 3. Equal 3. What will happen? I let v3 to be k1, k2, k3, k4. Yeah, it's a matter of calculation. Nothing is there. So I have, it's good practice, minus 2, 2, 2, 2 times k1, k2, k3, k4, 0, 0, 0, 0. What I have? It's 0, minus 1, 2, 2. And then 0, 0, 0, 2. The last one, 0, 0, 0, 1. Is it? Yes. So what I have? I have minus 2 k1 plus 2 k2 plus 2 k3 plus 2 k4 equal 0. I have minus k2 plus 2 k3 plus 2 k4 equals 0. I have 2 k4 equals 0 and k4 equals 0. From here, I have k4 equals 0. Plug it here, plug it here. What you will have? If I plug it here, I have what? K2, this will be 0. This will be 0. So I have K2 equal to K3. Plug that in the first one. So I have minus 2k1. Let me divide by 2. Let me do it in 2 steps. Minus 2k1 is equal, or let me say plus 2k1. Take it to the other side. So I have k1 equal k2 plus k3. And k2 is 2k3, so it will be 3k3. Yeah. So k3 is free variable. My free variable will be k3. So I let k3 equal 1. So it will be k4 is 0, gone. K1 will be 3, and K2 will be 2. So it is my V3. That will be 3, 2, 1, 0. 3, 2, 1, 0. Okay. Good. Huh? So the first one is 2, 1, 0, 1, 0, 0, 2, 1, 0, 0, 2, 1, 0, 0, 3, 2, 1, 0. Good. So now for lambda equal 4. Let me see what will happen. I let V4 now solve the system. I have what? 1 minus 4, that will be minus 3, 2, 2, 2. Okay. 0, minus 2, 2, 2. 0, 0, minus 1, 2. 0, 0, 0. What was the last one? 0. Now I need to solve these equations. I have minus 3k1 plus 2k2 plus 2k3 plus 2k4 equals 0. Minus 2k2 plus 2k3 plus 2k4 equals 0. Minus k3 plus 2k4 equals 0, and 0 equals 0. So from here, I'm getting that k3 equal to k4. Let me plug it here. I have, now I can divide by 2. So I have k2 will be equal what? k3 plus k4. And that equal what? K3 is 2k4, that will be 3k4. Now I plug it in the first one, I have minus 3k1, 2k2. K2 is 3k4 plus 6k4. 2k3, that will be 4k4 plus 2k4 equals 0. I write everything in terms of k4. So I have k1 will be 10 plus 2, 12 over 3, 4k4. Nice. So my free variable would be k4. I let k4 to be 1. So it will be k1, k1 4, k2. K2, where is it? Yeah, K2 from here. It will be 3. And K3 will be 2. So it is my V. 4. That will be 4, 3, 2, 1. Nice one. Okay. Now let me do 25. I think I have a repetition here. Okay. I have A minus lambda I. That will be what? 1 minus lambda 0, 1, 0, 0, 1 minus lambda 1, 0. Good. I have 0, 0, 2 minus lambda 0, 0, 0, 0, 2 minus lambda. So what I have 1 minus lambda. Let me do it in steps. Then I have what? This. Then very clear that will be 1 minus lambda. 2 minus lambda, 2 minus lambda. And that gives me 1 minus lambda square, 2 minus lambda square equals 0. So what are the eigenvalues? Lambda equal 1, multiplicity 2, and lambda equal 2, multiplicity 2. Let me see. Is there, we have 2 vectors in each one? Right. Is there something? Okay, so now for lambda equal 1, let V1 okay, so let me solve it. I have what will be the system? Lambda equal 1, so I have 0, 0, 1, 0. I have 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1. This is what I have. So what we have exactly, I have K3 equals 0, K3 equals 0, K3 equals 0, then K4 equals 0. So what are the free variables? Free variables, K1 and K2. No restriction on them. So what is my trick? I will let K1 equal 1 and K2 equal 0. Then I let K1 equal 0 and K2 equal 1. Everything is clear. So I have what will be V1? V1 will be 1, 0, 0, 0. From here, I'm getting V2. That's 25, correct? Yeah, that will be 0, 1, 0, 0. So I have the E1 or V in R4. So that what? A minus I V is equal to 0. And that will be spanned by V1 and V2. And this I can write it as alpha V1. Let's write it again. V1 plus beta V2. That alpha and beta are real. So I have 2-dimension with bases V1, V2. Okay. Now let me do the second one for lambda equal to. See what will happen. I let V3. I'm not sure I have V3, V4, or V3 only. Let us see. I have now lambda equal what? 2. Lambda equal 2. So let me do it. I have minus 1, 0, 1, 0. Okay. 0, minus 110. Is it? Yeah. Then 0, 0, 0, 0, 0, 0, 0, 0. Yes. So what will happen now? I have minus K1 plus K3 equals 0. And I have minus K2 plus K3 equals 0. From here, I'm getting that K1 equal K3. From here, I'm getting K2 equal K3. Okay. Not only that, K1, there's K4, no restriction in K4. So my free variables are K3 and K4. These are my free variables. Since I have two, I'll do this trick. K3 equal 1, K4 equals 0. And I have K3 equals 0 and K4 equal 1. Oops, I will not do this. That's it. Now it will be what will be K1 in this case? K1 equal 1 and K2 equal 1 also. So I have my V3 that will be 1, 1, 1, 0. Here, what will be K1? K3 equals 0, so K1 equal K2 equals 0. So it will be V4. That will be 0, 0, 0, 1. So I have E2, which is all V in R4, so that A minus 2I V is equal to 0, and it will be spanned by V3 and V4. Also, I can rewrite it alpha V3 plus beta V4, that alpha and beta are real numbers. So I have two dimension and bases will be V3 and V4. Yeah. Let me do the next one since I put it here. Yeah, so I have A minus lambda I. See what will happen. So I have 4 minus lambda 0, 0 minus 3, 0, 2 minus lambda 0, 0, 0, 0 minus 1 minus lambda 0, 6. That will make a big problem. 0, 0 minus 5 minus lambda. So that will be what? 4 minus lambda. Cancel this with this. Very clear, I have 2 minus lambda minus 1 minus lambda minus 5 minus lambda equals 0. So what are the eigenvalues? Interesting. It's not the same one. 4 minus lambda, 2 minus lambda minus 1 minus lambda. Cancel this with this. Now we go to this times that. Oh. No, 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 no. Yeah, wait a minute. But it's not correct. Yeah, I need to choose the second column. I think choose this better. Not the first column. I choose the second column. Or the first or second row. Since I have numbers here. I cannot do it this way. So I have plus minus plus. So I have 2 minus lambda. Be careful. I cancel this with this. I have what? 4 minus lambda, 0. Interesting calculation, this one. I have 0, minus 1 minus lambda 0, 6, 0, minus 5 minus lambda. Now we'll do the same thing. We'll do the second column also. I have what? 2 minus lambda minus 1 minus lambda. Cancel this with this. I have what? Let me do the calculation right away. I have this. I have lambda square, 5 lambda minus 4 lambda plus lambda. 5 lambda plus lambda. Okay. I have what? Minus 20 plus 18. So that will be 2 minus lambda minus 1 minus lambda, lambda square plus lambda minus 2. That is what? 2 minus lambda minus 1 minus lambda. I have lambda plus 2. Yeah, lambda plus 2 times lambda minus 1. So what are the eigenvalues? Yeah, be careful with the calculation. Eigenvalues. They will be what? Lambda minus 2 and lambda minus 1 and lambda 1 and lambda 2. Now let me do it step by step. For lambda equal minus 2, I let V1 to be this. See what will happen. Yeah, that will be 6, 0, 0, minus 3. Zero, 2 minus 2, that will be 4, 0, 0, 0, 0, minus 1, minus 2, that will be 1, 0, 6, 0, 0, minus 5, that will be minus 3. So what we have? We have 6k1 minus 3k4 equals 0, 4k2 equals 0, k3 equals 0, 6k1 minus 3k4 equals 0. So I have in a k3 equals 0, k2 equals 0. These two are the same, and I'm getting what? K4 equal to K1. Yeah. So K1 is my free variable. Free variable will be K1. Let K1 equal 1. K4 will be 2. Yeah. So it is my V1 will be 1, 0, 0, 2. Nice. Now for lambda equals minus 1. Let me see what will happen. I let V2 see the system. 4 minus 1, that will be 5, 0, 0, minus 3. Okay, 0, 3, 0, 0, 0, 0, minus 1, minus 1, that will be 0, 0. Good. That will be 6, 0, 0, minus 5, minus 1, that will be minus 4. So what I'm getting? I'm getting 5k1 minus 3k4, that is 0, 3k2, that is 0, 6k1 minus 4k4, that is 0. From here I have k2 equals 0. I can solve these two equations. How to solve this? Multiply the first by minus 6 and the second by 5. So I have minus 30k1 plus 18k4 equals 0. Multiply the second one by 5. So I have 30k1 minus 20k4. Add them. I'm getting what? Minus 2k4 equals 0. So k4 equals 0. Plug it in the first one. I have k1 equals 0. What is my free variables? There's no restriction in k3. So k3 is my free variable. So I let k3 to be 1. So it is my v2. Everything 0 except k3. That will be my v2. Okay. Now let me move to the next one. Lambda equals what? 1. Now for lambda equal 1, I let v3 now to be k1, k2, k3, k4. That give me what? What will be the system? 4 minus 1, that will be 3. 0, 0 minus 3. 0, 0 minus 3. That will be 0, 1, 0. And 0, 0. Minus 1, that will be minus 2, 0. Six, 0, 0 minus 5. So it will be 6, 0, 0 minus 6. So what I have, 3k1 minus 3k4 equals 0. k2 equals 0. Minus 2k3 equals 0. 6k1 minus 6k4 equals 0. And I have k2 equals 0. I have k3 equals 0. Here I have k1 equal k4. And here the same thing, I have k1 equal k4. So my free variable will be k4. Let k4 equal 1. I have k1 equal 1. So it will be my v3. 1, 0, 0, 1. That will be my v3. Now for lambda equal 2, the last things, I let now v4 to be k1, k2, k3, k4. Let's see what will happen. Lambda equal 2, so I have 2, 2, then 0, 0 minus 3, 0, 0 minus 3. You need to solve the systems the way you like. But always they have really many solutions. They have 0, 0, 0 because of 2, 0, 0, 0. Okay, nothing is here. I have 0, 0, minus 1, minus 2, minus 3, 0. Then I have 6, 0, 0, minus 7. Am I right? Yeah. Minus 2, minus 5, minus 2. So we have what? 2k1 minus 3k4 equals 0. Minus 3k3 equals 0. 6k1 minus 7k4 equals 0. From here, I'm getting k3 equals 0. I need to solve these two equations. Multiply the first by minus 3. So I have minus 6k1 plus 9k4 equal 0. This one the same. Add them. I'm getting 2k4 equals 0. So that means k4 equals 0. Plug it in the first one. I'm getting k3 equals 0. Who is my free variable? K2. Free variable will be my K2. So I let K2 equal to 1. So it will be V4. That will be 0, 1, 0, 0. And that's it. I think we did good number of questions from the book, including the suggested problems. So let me stop the recording. I think we did a long video a little bit. Thank you.